Hey guys, welcome to lesson 18. In this lesson, we're going to talk about dividing polynomials. When we learn to multiply and divide, we introduce the concept of long division. Which is useful when dividing big numbers. We can also use long divisions on polynomials. All right, so a couple things you need to know right out of the gate. Every power must be represented from highest to lowest, and long division always works. The bulk of this lesson is going to be using synthetic division, which we'll talk about in a second, but it works some of the time. And I'll explain to you when it works and when it doesn't when we get there. But here's the long division always works. So on this problem right here, 3x cubed minus 2x squared minus 150 over x squared minus 4, you have x cubed, x squared, but you don't have an x. So I need to include that when I write it. And then on the bottom, I have x squared, but I don't have x. So I need to write that out as well. So I have x squared plus 0x plus 4 or minus 4 on the outside. And on the inside, I have 3x cubed minus 2x squared plus 0x minus 150. Again, I included the 0x in the outside and the inside to make sure every power was represented from highest to lowest. Okay, now, this looks tedious or complicated or whatever adjective you want to throw out there, but it's not that bad. To get this thing started, you want to focus on the first term on the inside, the first term on the outside. So I want to know what times x squared gives me 3x cubed. Well, that is 3x squared. Okay, and then once you have that term, 3x. And then once you have that term, you're going to multiply by everything out front. So I'm going to take 3x and multiply by all three terms out front. So that's going to be 3x cubed minus, 3x times 0, that's going to be 0x squared. And then 3x times 4 is going to be minus 4x. All right? And remember, in long division, you subtracted everything on this line. So I'm going to change all my signs. So I got negative, negative, and then positive. All right, that forces this to fall out. And then I just add up everything else. So I got negative 2x squared. I got positive 4x. And then I bring this down, and I got negative 150. All right, then I start the process again. X squared times what gives you negative 2x squared? Well, that's simply negative 2. All right, so do it again. So you got negative 2 times x squared is going to give you negative 2x squared. Negative 2 times 0 is 0. And then negative 2 times negative 4 is going to be positive 8. All right, subtract your line. So you're changing all the signs. So you got positive, negative, negative. All right, so that falls out. And so 4 plus or minus 0 is still 4. So I got 4x minus 158. All right. The good thing about polynomials when you divide is that when you're out of terms, you're done. Oops, I made a mistake. Way up here. 3 times 4 is 12. So that should have been 12x, which means that should have been 12x, which means this should be 12x. All right, so once you're out of terms, you're done. So if you have a remainder or not, you'll know as soon as you finish up with all your terms. All right, you got 12x minus 158, which are out of terms. So 12x minus 158 is my remainder. If this was 0, 3x minus 2 would be my answer. But since it's not, I got plus 12x minus 158 over what I divided by, x squared minus 4. Okay, so that's my answer. And that's how you do long division. Now, however, when given a polynomial in x is divided by a first degree polynomial of the form x minus k, a shortcut method is called synthetic division. And from synthetic division, we acquire a useful trick called the remainder theorem. All right, so what does all that mean? Well, in this first problem, we talked about we divided by x squared minus 4. All right, that's something you're going to want to use long division for. If this was 2x, or let's say if there was a number in front of x that's not 1, you would still want to use long division. But here, we have x plus 2. If we set that equal to 0, we get x equals negative 2. And so negative 2 is what I'm going to divide by. So I got negative 2. And then synthetic division says I'm going to divide only using the coefficients. But once again, every power needs to be represented. So I got x cubed, x squared, x in a constant term. Everything's there. So I'm going to say 5, negative 6, negative 28, and negative 2. Now, follow closely. The rules of synthetic division are simple. The first term, 5, always comes down. I just bring it below the line. And then I take the 5 and the negative 2 and I multiply. And I put that product underneath the next number. So 5 times negative 2 is negative 10. I put it right here. And then I add my column. And remember, when you add, if the signs are the same, you add and keep the sign. If the signs are different, you subtract and take the sign of the larger. Okay, so you got negative 6 and negative 10. The signs are the same, so I add and keep the sign. So it's going to be negative 16. And then I start the process again. Negative 16 times negative 2 is going to be positive 32. Add, my signs are different, so I'm going to subtract, take the sign of the larger, so it's going to be positive 4. Do it again. 4 times negative 2 is negative 8. Add your signs, or add your numbers. The signs are the same, so I'm going to add and keep the signs, so it's negative 10. All right? Now, I started with x cubed. I divided by x. So, again, these are coefficients. And I write my answer, 5x squared minus 16x plus 4. And then this last number, the negative 10, is where your remainder lives. And since it's negative, that's going to be minus 10 over x plus 2. So you started with x, you're going to finish with x. And so that's how you do it. That's synthetic division. All right, on number 2, I got x minus 3 on the bottom. So I set that equal to 0. I get x equals 3. So that's what I divide by. 3 on the outside. I draw my box. All right, so I got x cubed, x squared, x in a constant term, so everything's good there. 4, negative 15, 11, negative 10. 4 comes down, and then I multiply. 4 times 3 is 12. I add my column. The signs are different, so I subtract, take the sign of the larger, so that's negative 3. I multiply. Negative 3 times 3 is negative 9. Add your column. The signs are different, so you subtract, take the sign of the larger, so that's going to be positive 2. Multiply, you get 6. Put the 6 under the 10, add your column, and you get negative 4. Okay, you start with x cubed, you divide it by x, so 4x squared minus 3x plus 2 minus 4 over what I divided by, x minus 3. You start with x, you finish with x. All right, so that's how that's done. Now, the remainder theorem, all right, I've already told you where the remainder live. It's your last answer in the box. Okay, so on number 3, it says find f of negative 3. So that tells you straight up what you're dividing by. You're going to divide by negative 3, and then you're going to do synthetic division. You got x to the 4th. You don't have an x cubed, so I need to make sure that's there. X squared, x. All right, so I got negative 1, 0 for the x cubed, 3, negative 4, and negative 5. Okay, I don't know what the remainder is going to be, but we're going to find out. All right, so I bring the negative 1 down. I multiply, I get positive 3. When I add, I get positive 3. When I multiply, I get negative 9. Add and take the signs are different, so I subtract, take the sign of the larger, so I get negative 6. Multiply, you get positive 18. That's going to give you positive 14. That's going to give you negative 42. And so that's going to give you negative 47. So what this is telling you is that if you plug in negative 3 into this function, you're going to get negative 47 as an answer. Okay. Number 4. It says f of 4, so I'm going to divide by 4. All right, I got x to the 4th is my highest power, so I should have a third, and x squared, which I don't, so I need to include that, x in a constant term. So it's going to be negative 3, 15. I don't have an x squared, so I got 0, negative 50, and 25. Bring the negative 3 down and get started. Negative 12, it's going to be 3, 12, 12, 48, negative 2, negative 8, 17. So this tells you that when you plug 4 into your function, you're going to get 17 as your answer. Okay, so for 3 and 4, we did the remainder theorem. Okay, and we did synthetic division, and we found on 3 that if we plugged in negative 3, we would get negative 47, and we found that with synthetic division. So when dealing with the remainder theorem, you can use synthetic division, or you can simply just take like negative 3, plug it into your equation, and crunch your numbers, get an answer. So you have 2 different ways of looking at it. You can use synthetic division, or you cannot, but that's how you do it. Now, a 0 of a polynomial function, f of x, is the number k such that f of k equals 0, meaning that if I have a remainder of 0, that what I divided by is a 0 of the function, meaning at that point it crosses the x-axis. Real number zeros are the x values of the x-intercepts of the graph of the function. So we're trying to decide whether or not these are actually zeros of the function. Okay, so on number 5, I'm dividing by 1. All right, so I got x cubed, x squared, x, and 0, so everything's there. I got 1, negative 4, 9, and negative 6. 1 comes down, and I start the process. 1 times 1 is 1. That's going to be negative 3, 6, 6, and 0. All right, since my remainder is 0, yes, this is a 0 of that function. All right, number 6. I'm dividing by negative 1 this time. I got x to the 4th. I don't have an x cubed, so I need to make sure I put that in there. X squared, x in constant term. So I got 1. I don't have an x cubed, so I put a 0. 1x squared, negative 3, and 1. All right, 1 comes down. I get negative 1, positive 1. So it gives me 2, negative 2, which is negative 5. And it's going to give me positive 5, which is 6. 6 is not 0. That's my remainder. But since it's not 0, this is not a 0. Not a 0 of the polynomial. Okay. 7. Dividing by 2 this time. 2. All right, I got x cubed, x squared. I don't have an x, so I need to make sure that's there. So I got 2, negative 3. I don't have an x, so I put 0, negative 18. Bring the 2 down, get started. So it's going to be 4. It's going to be 1, 2, 2, 4, negative 14. So once again, I got a remainder, but that remainder is not 0. So this is not a 0 of the polynomial. Okay, 8, last one in this lesson. All right, I got x to the 4th, x cubed, x squared, x in a constant term. So everything's there. I'm dividing by negative 3. All right, so I got 1, negative 4, negative 14, 36, and positive 45. All right, bring the 1 down. That gives me negative 3, which is negative 7. It's positive 21, which is 7. That's going to give me negative 21, which is 15. And it's going to be negative 45, which is 0. I have 0 for remainder. And because it's 0, it's also a 0 of the function. All right? So that's it for this lesson. Hope you got something out of it. Reach out if you have any questions, and I'll see you in the next one.